Hey guys, very good morning to all of you. Hope you guys can hear me and can see my visual as well. Please do confirm if you can see my screen and you can hear me pretty well. Thank you very much for the confirmation, Ankit, Jitesh, Gauri. So we're expecting a couple of more candidates. So please wait for a few more minutes, maybe 2 to 3 minutes or 4 minutes, and then we're gonna get going, guys. Thank you very much. Stay tuned. Okay, guys, once again back and good morning to all of you. Hope you guys can hear me and my visual is clear too much. Okay, Supriya is saying I missed my last class. That is my first class. Could I listen anything else? Okay, no problem. So there will be some issue at the. You saying could not listen anything. Maybe some technical issues or what. So you can see the recording. Do let me know if you can really talk about a bit of them. Anyhow, we're gonna recap a little bit. So that's fine. We can do that. So guys, you're good to go. I think being people have taken time to joining in, let them join in. So we're gonna do some recap for the previous first class, and definitely we're gonna start the new one. Would like to talk about a bit of that Aadhaar customer. It was not Huttonworks, it is Mapper. So yesterday we have said okay, we'll be showing you that customer. So Aadhaar, which you can see that, and Mapper is the technology distribution who did it for us. So it was my apology. Anyway, so let's talk about a bit of the previous class and then we can start off today. And we're going to be speed up from today because yesterday was the first class and we took a lot of time for introduction and a way back. We'll have to just manage those timings. I hope people have still joined. I think I can see all of the people are joining in. Good. So let's go back and have some quick information for yesterday's class and see where we're. So guys, how many people have already they have seen the okay, what is big data and big data is a challenge. Big data is not a technology. Big data is a platform. So how many people can say yes or no? Do you guys agree with me? Like I said, big data is not technology. Big data is a platform. Okay, let's see how many people says. Oh, Amit says yes. Yeah. Oh, good. Everybody. Del Prato also says yes. Okay, good. Thank you very much for confirmation. So yes, big data is actually not a technology. It's a platform where it's going to be helping you the come up with traditional challenges which you used to see with the capture, storage. So that is definitely is talking about more or less with this volume, velocity, variety, and veracity. So I have one more. There are a lot of people was having confusion in terms of veracity. I have taken one more notes for you guys. I've worked a little bit more for you guys to make you understand. Yesterday we seen how these Amazon, stock market and email comes up in a bigger way. So let me make it bigger so that you guys can see that. Fine, we see that structured, unstructured, and semi-structured data, how the growth is happening and why it started 2005 because of the social media launched and so on. So we have been, the data of RDBMS, which is a structured is linear growth versus the unstructured and semi-structured gonna be more exponential growth. Okay, you see in volume, velocity, variety, and you know veracity. So veracity we also talk about not to take out all the data. At the same time, it says because of it's due to some technology issue. We'll talk about more. We don't have schema on write. This is schema on read. So the kind of different data you're storing, which is structured, non-structured, and semi-structured, the data would be inconsistent. Data cannot be very clean. So there would be always be challenge to clean the data. And let me have few stuffs for you guys. Okay, so IBM has this bigger, too big kind of stuff. So you can see veracity is uncertainty of data. 37% of respondent. So you can see we have volume, we have variety, velocity, and variety. So sorry, in this veracity we're talking about the data has been keeping everywhere because you have everywhere data. You're just keeping in here, putting in a Hadoop in place. Data may not be consistent. It will have to clean the data because number one, we are actually taking data from different sources and putting it one place, and we're definitely having data on a centralized way, but we are a distributed manner. But we are not stopping people to, okay, do not store structured data, unstructured data. So we are actually, what we're doing, we're taking all the data. And that's what the concepts of inconsistency or the blank, you can see that the rows was blank here in the third row. So in having said that, if it is schema on right, which is in a normally say in a RDBMS happens traditional way, then the blank will not be there. So veracity is also a very important topic, and people would also have to think upon that. Okay, so wanted to have this clarity for you guys. Okay, volume. So let's have a small discussion once again. So people are having some question. Volume, definitely increasing your volume in terms of the data size. The capacity of your data is growing day by day. So if you can see that volume growing from 2005 till today, that's what the graph is being shown here. And let's show you that. See this, the volume is growing. So this is exponential growth on unstructured data side, whereas if you talk about structured data, is very linear growth. See, very small one. So this is what the volume growth. Velocity, the speed the data is being generated. For example, sensor data is being really fast per second. So many logs are there. Variety, we see that different kind of a structured, unstructured sensor data has been coming in, and veracity, we already spoken now. I hope you guys been clear so far. Any concepts where I can help you? I'm just doing a little kind of a, I would say fallback and kind of a backup steps. So you guys have already seen, and we have gone through it. So having said that, we have spoken for recommendation engine, how the recommendation works. It is a person-based recommendation rather than a database recommendation. Today, if we talk about a big data, and then we have ad targeting, all right? So, so Anubhuti says, can we say that structured data is which lies on computer HDD? Okay, Anubhuti has a question. Okay, so let me explain this. Anubhuti, can you hear me? Is your mic working, Anubhuti? Can you speak up?
Yeah, am I audible, Indra?
Yes, yes. To answer your question is, HDD is you talking about hard disk drive?
Yeah.
Everything gonna store in hard disk drive. But let me talk about when you say structured, it is RDBMS, table data,
Okay.
right?
Okay. Okay.
Unstructured video, audio, log.
Yeah.
Semi
Audio.
structured
Yeah.
XML, right? So
Yeah.
everything going to store in
Yeah.
hard disk only. The way of storing data.
Okay.
When you say structured data, the table has its own format: name, address. You know,
Yeah.
you will have
Schema. Yeah.
maybe you'll have address as a 40 character, first name is a 30 character. That is structured.
Yeah.
So you cannot put anything blank there. It has to be always validated, right?
Okay.
That's called schema
Okay.
on write.
Okay.
Whereas RD, we'll talk
Okay.
about more, little more. It is not reading
Hmm.
any structure. Hadoop says you can give me anything. I'm okay to accept,
Yes.
right?
Yes.
Does it answer your question,
Yes.
Anubhuti?
Yeah.
Okay,
Yes.
thank you very
Yes,
much.
Indra. Thank you. Thank
Okay, Karan says how to store unstructured data, sensor data stored in. Okay, well, good. To answer your question, we have to have some programming languages coming in. So we'll have Java, we'll have definitely Python coming in. Karan, can you hear me? Is the mic working? Okay, I'm unmuted to you. Can you speak up to me? Fine, looks fine. There's some issue by right. So there would be a programming language interventions, where is a Java or a Python or R, where you can read the data from sensor and storing it. So Supriya says, hash maps. Yes, a kind of data. Fine. So let's go back once again. Bit of questions was coming from the candidates. So we've seen the recommendation engine, how it really works. Ad targeting. Oh, thank you, Karnak. Thanks for the response. We have seen how the target the ads according to that person who is doing what search, and then we have a search quality. So I've told you that person who's searching for more traveling. So definitely if you search something any specific country, the traveling will come. person is more interested in news and kind of a political news on other shoes or the news, he will be having the same quality. Abuse and click fraud detection, we already spoken. If you have YouTube video loaded by you, you cannot click 10 times, or you cannot subscribe yourself, or somebody else with the same IP address cannot be. Okay, telecommunication, very important aspect when you have multiple customer, and if you feel that the customer is actually moving away from you and going to the next vendor, so you can figure out the churn, how the churn is happening, why is happening. Is customers having more benefit with other vendors? Is like the plans are more better than us, or what? Network performance optimization, you need to see that how you can perform better in terms of the frequency in networks. So your frequency dropouts, your frequency goes away, you definitely optimize them. Calling data records, so like CDA analysis, you talk about, okay, the calls comes up, every call is being there, you can figure out, okay, how much number of calls is there in a day, which is the bigger call and what is the duration of the call, and so on, specifically the call recording analysis. Analysis network to predict failure. This talks about, okay, how much drop-offs is happening for a couple of months, and how your growth in terms of frequency catching, not dropping, servers are down, how it is happening, and next few months, and maybe tomorrow for that matter, how the network should be. So that was more or less from a kind of a big data customers, the real scenario people are using it. The next one we said the government, especially Indian government, have started fraud detection and cyber security, welfare schemes, and definitely the justice one. So I have already spoken yesterday that, okay, we were actually, I was the name was little different, so it's not that Hutton Works, I'll tell you why I remember. There's some reason behind. So Mapar is the company who have really spoken about Aadhaar card. So if you can click on Aadhaar, so Indian Aadhaar card is the largest biometrics. So you can see that this is what they did it, and they've already had a kind of some world warfare kind of a seminar, and they have presented perfectly for this Aadhaar card. So I remember why talk about Huttonworks, because Huttonworks is based in Indian guys who have started in US, and Amit is the guy who being started. So if you talk about Huttonworks especially, and you figure out who's the board member, so I could remember we were actually having a meet in Bangalore, so we met a couple of people here. So if I talk about who is what, and if I go to the management team, so you figure out Amit is also there, and Arun is there. There's so many people there from India. So if you talk about Arun Murthy, you talk about Amit, those all actually coming from India. The background is from India. So you can see that Arun C. Murthy, actually he is based from Bangalore. This company was originated in India, and then they settled down in US. So that is the reason I thought, okay, I remember something specific. All right, can you see that? This is just for information, guys. So Mapar, the company who was initiated in India, and then this is what the largest biometrics identity system improves health and welfare service to the poor. It's not for poor, it's for complete everybody in India. Okay, so that was, we were talking about how this Aadhaar has been taken. So the question must be coming from you, is government is also looking forward to see the big data? So the answer would be yes, because now big data is the biggest hub now for any platform, and is something going beyond capacity in terms of all 3 V's and 4 V's. Big data always in a place. Healthcare and life sciences, I think you guys been pretty much aware how much is important. So health information exchange, you having all information kept it one place, do the analysis, figure out the new technology coming out, and it's going to help you your data. Genetic sequencing, so there would be a genetics where you have your DNA comes up in place, and you figure out the DNA matching. So when a baby borns, there would be specific DNA, and the actual DNA going to be match. It's going to be 500 to 500 metrics, or 200 to 200 metrics. So the DNA comes into the rows and columns format, x and y kind of x, y, z kind of coordinates, which you generate with the actual matrix. Serialization, healthcare service quality improvements, and drug safety. So if you talk about everywhere, big data platform is being actually using in. So these are the biggest places where big data is already in place. Now, banks and financial services, no way. If you take out a big data now, you are actually cannot do anything else. So it is very important. So, for example, you have a modeling through risk, threat analysis, fraud detection. So somebody is using your credit card today at morning 8 o'clock in one of the country in USA, and then at the same time at you talk about maybe UK or London or somewhere else, the same credit card is already swapped. So another 10 minutes you get a call from a bank saying that, hey, Mr. X, your credit card is already swapped in UK. Can you just confirm it is the same, are you have done any transaction? Because definitely, in 2 hours time, you cannot fly from US to UK. It's impossible. So the fraud detection and, it is very important to get your data. But now you say, how come on a big data and giving you a 2 hours live kind of stuff. So I can ask this question to you guys. Anybody who understand what my example is talking about? I'm saying you taken a fraud detection. Is it possible in 2 hours? Can Hadoop can do that in 2 hours? Hadoop is a batch processing system. How come in 2 hours you can get the kind of a fraud detection? Anybody can think? Can give me an answer? Do you think so? The Hadoop can do that? Real-time replication, personalized saying, not if check platform previous data. Okay. Ananta says yes. Okay, so using Spark real-time streaming, Karthik, good. Fine. So a lot of people says yes. A lot of people says, the people are being, few people are confused, few people have not given answer, but I think a lot of people are aware. Kafka is yes. Fine. Abdul says yes via stream data. Good. So there would be streaming, guys. So it's not possible all the time that you only do a batch processing. So you want to do a streaming. So streaming is a process, is a continuous data pumping. Now there would be still having some intervals. It may be 1 minute, 2 minute, and 5 minutes, depending on what intervals you guys have decided. You can pump in the data, and then your analytics comes in place. So the thread and a fraud can be taken clear in this if your data is already there. So the moment you have a transaction, you put it in, and the moment you have a next transaction, you put it in, and you figure out what is the time frame, where's the geography, and then you can catch that fraud to be happened. So we'll talk about more in detail. Okay, Supriya says the explanation is not clear about. Okay. So Supriya, what happens if we have a data coming out? So if you do a credit card as a data coming out to you, and the bank, what it does, the credit card is actually coming to the bank. So once you've done a transaction, it goes to the credit card system. Then you have a streaming. So we'll have a transaction system, and we will take the data into Hadoop platform, which is in every minute or every 10 seconds or maybe particular intervals. Then what you do your analytics on your streaming. So you do not wait for batch processing to get all the data coming in. We'll definitely have to talk data every minute, and your analytics runs every 5 minutes and 2 minutes, and that's how you can figure out the data which is in Hadoop platform can do the analytics. We're gonna talk about more about this in Supriya later on when we actually going forward to see them in couple of area where you have a Flume, Kafka, and Spark coming in. So which technology does the streaming does analytics? Amit, the technology would be again, it can be Spark, it can be Kafka and Flume. Wherever the streaming is comes, this is what we are trying to explain you. Streaming is a process of pumping, especially an unstructured data or especially a log data in every intervals. Okay, so Supriya, can you hear me? Is it your mic is clear to you? Supriya, can you come up? Okay. Can you hear me, Supriya? Can you speak up? Okay, looks like the mic is issue. Guys, am I audible to you, everybody? Okay, so I'm getting all the responses says yes. Thank you very much. So people who has a sound problem and some kind of disturbance, please log off and log in. Thank you very much. Okay. Okay, so I've increased the volume of mine as well. So JP Morgan Chase is the biggest one. They're using, and a lot of banks are using started now. So, Sears is one of them. So they have a point of sale transaction analysis, customer churn analysis, sentiment analysis. Now let us, talk about a little more, from Sears point of view. This is one of the case study which Sears was actually improving their data, and the business case was being, improving day by day. They use SAS, they use Oracle, they used, Teradata to keep their data going. And but I've already told you yesterday we have spoken something for vertical scaling. So how many people have still remember vertical scaling, guys? So this is what is happening in vertical scaling, and they move to a Hadoop platform. So do you think vertical scaling you already heard yesterday? Do you understand vertical scaling, guys? Can I get the answer? Okay. So Bhushan says yes. Ganesh says yes. Okay. Amit says yes. Good. So a lot of people. So let me have Amit. Can you hear me? Am I audible to you?
Yes,
Yeah. How are you?
yes, I'm good.
Okay. Good. So do you mind explaining what is the vertical, scaling we did yesterday? Why we do that?
Yeah, yes, sure. So vertical scaling means that we are scaling up the same machine, like we are adding extra RAM, extra hard disk, or extra
Hard
CPU
disk
maybe
RAM CPU.
to
Yeah.
process,
Mm-hmm.
yeah, to process the like more and more data which we comes across every time our internal data grows in size.
Correct. And
So
where do you
rather than
find
having multi
correct? Where do you find a limitation?
limitation would be that obviously there should be some limit of how many hard disk we can add in our machine or how many like, how much CPU we
Mm-hmm.
can have. There should be some limit, right?
Correct.
How
So
many?
yeah. Okay. Thank you very much, Amit.
Thank you.
So as Amit already described here, so yes, we have a RAM, CPU, and definitely you got a hard disk. So the extension you may can have multiple hard disks, that's fine, but there's a CPU and memory would be again intact to that. It's like a universal, same whatever the capacity you have on hard disk, the CPU should be able to support that. A memory should be able to support that. So there would be scaling done at certain extent, and then it says no, the limitation is over. You may have to shift, and that's what there's they're actually directly proportional to everything. So hard disk is directly proportional to CPU, and the CPU directly proportional to memory. You cannot say my CPU can use n number of memory or n number of hard disk, right? So what happened is the inside of data can provide you a business advantage, and everybody, that's the reason they do that. And if you say if you're not able to get your data, then you are definitely business going to impact, and your analysis may not taken place. So Sears has a tremendous pressure in getting data. So they have traditionally, like, they have used Oracle Exadata, Teradata, and a lot of big servers altogether, but at the end they would not succeeded. Reason being, they're having a vertical scaling, not the horizontal scaling. We'll talk about horizontal scaling soon when we speak about everything. So they shifted to have your, so you can have a case study, let's say holding corporation, which talks about a big data platform and so on. Good. So now we are coming actually the this is what we talk about, a limitation of existing data analytics architecture, which is based on relational database management system, and then we'll move to your big data. Looking at this diagram, how many people understand what we're trying to achieve here? What do you think we're doing it? So I've already said limitation of existing data analytics architecture. That means this is definitely based on your traditional database architecture, right? It is not a Hadoop platform at all. So the first of all, if you see, so let me give you a brief, so let me have this. So if you talk about this, if you see this talks about instrumentation. So this is talking about kind of a ingestion of your data. Ingestion is basically, when I'm talking about a technical term, would be taking your data from different sources and you are loading the data at one place. So if you talk about ingestion, coming out from different locations at this place, right, is going to your system, and you actually collecting those data coming out from different locations. So what happens? The storage only grades. So if you talk about storage, as we already spoken before, the hard disk drive can be expanded at certain limitation. So when you talk about you storing those data, volume has been growing and coming out from different locations, and you collecting the data, right? So mostly what you're doing is actually appending them. So there would be an issue. You can see that the first important challenge, the processing. Can't explore original high, kind of a fidelity raw data. So if you talk about a huge data, as you said, the capacity would be as limited. So definitely we would not go for a detailed level of data. You will go for kind of a summary data. For example, you have a yearly data, you may not be going for a day level data. And then if you're missing a detailed information going further, any report or anywhere you must be needing those data, right? Now, moving data to compute does not scale. So definitely the second challenge is like you have, when it comes to the computation, when it comes to the calculations, because of data is not much and the capacity of moving data from one to another. If you have one grid to another grid and they have, let's say 100 GB of data, it would be challenge to, have one server transporting to another server and do some calculation. And when you say also, when we talk about moving, it's a network packet is being actually using when you're going from one system to another, and that's what the system gets slow, and this again are limitations. So if you talk about 90% of the data, you can see that premature data, data death. That means you do not have those data whichever you want, and whichever analysis you wanted to do, it is actually premature data death. You do not ever wanted to get into what actually you want to achieve. So 90% time what happened, the data is there or may not be there, you may not be reach your analysis, you've been completely gone. So it says you have this limitation in terms of storage. So first of all, you can see that there's a storage issue, right? There's a processing issue, right? There's a computation issue. Fine, you do not get all your data. I see that the premature data is there, you're already getting data is already gone. It's been coming up to that, it's not even understanding where the data has been keeping. So Prasanna says, can we get multi-dimensional reporting possible, like cube, drill ups, downs? Yes, Prasanna, it's been possible, but yeah, that we are not scaling up. So let me have the small discussion with Prasanna. Can you hear me?
Yes, sir.
Okay.
Yes, Indra.
Okay, so what had happened, it's not a question of the kind of storage you're looking in. It may be table or cube, right? But when I'm talking about, again, cube is the storage, right? Which is taking data from your schema, which is a star schema or a snowflake schema. Those are actually coming out from relational database, correct?
Yes.
So when you say the data volume, it is not too much, then cube will also not be published too much, right? Cube is only storage. I'm talking about data in, GBs, a petabyte and gigabyte. So the capacity of database itself is going down. So cube is definitely smallest part. That would not going much ahead. So doing a vertical scaling is fails. That's what we are talking about here. So does it
No,
answer
I
your question?
understand. I understand that, but what's my point is here, like, because we are talking about the raw data and like the lower level of data and all those kind of things, right? Doing reporting.
Yeah.
So can we let that high level summary and drill down to the lower level, and all those things can be possible in this. So
Yeah,
that's my.
possibility is there for that's a small rate of data. So how much data you can put in a cube? What do you think? A gigabyte? A petabyte? No.
Mhm.
The answer is
No,
no.
like
Yeah.
as of today's scenario, like maybe in terabytes.
Yeah, so
Is
that's
what.
again a limitation, right? Isn't it
Mhm.
the possible data, that premature data, that what we spoken just now, it is happening. So if I wanted to compare, for example, 20 years of a credit card of behavior of yours, let's say you must be using credit card, Prasanna, right? For a long back, you must be
Yeah.
using for 10 years or 20 years. If your bank wants to do your a kind of a buying pattern of yours, will that be possible today with traditional system?
Yeah, that is not possible for sure
So
because
the
limit.
analysis is not done. You don't make any decision. Let's say tomorrow I have to award you that you're using our bank card for last 20 years, so we'll give you the next card is free. How do I do that? I can't do that.
But one thing is like as we always know, like when it comes to BI and data warehousing. I mean, I'm from that back,
Same
so
here.
it
Go
is
ahead.
like that is like a decision support system kind of like reporting, right?
Correct. So, but you go for limitation, isn't it? You go for 2
Yeah,
years,
where
5 years data.
like top management will be requiring this kind of data to do the reporting and to take decisions and all. But do they really need that detail level data to go back and do that analysis?
So
So
you are actually restricting analysis, person. Don't you think so? You being because technical limitation is there, and you're saying you're going to convince your customer. If I say yes, I need it, then what do you do? You don't. I am actually coming from the same background. I work for RBS and HSBC. We had the same issues. We have said we cannot go for 10 years of
mhm.
data because of capacity is not there. Number one, there's no business case. Number two, there's no use. But if you talk about Hadoop, it does not talks about. For example, Aadhaar card in India, right? Now Aadhaar card is for almost 5 years or 6 years or 8 years story, and every day is Aadhaar card is happening. So don't you need all the data at one place when you do the analysis? So just imagine. So when I'm going for analysis in a bigger way, and it's not only the structured data, it could be unstructured. For example, your Facebook data. Do you think you want to destroy your data? You go to your Facebook. Whenever you started, the data is still there, right?
Yeah, that's correct. But what's my concern is uh, like BI and that particular reporting is for the top level management. So this particular platform, I think uh, it is a middle level management kind of decisions and all. Can I say like something like that? Maybe on top of that, also you can derive the summary and do the reporting.
Yeah, but it's fine. But Prasanna, we had spoken for one concept, but you have not understood the other one. For how about the commodities hardware? We'll talk about it later. Whenever you're going for
All
Cube and
right.
all, you're going for proprietary, right? Cube is not free. Talk
Mhm.
about Microsoft, IBM, Oracle. All cubes are paid, right? You process the cube.
Right, right.
You need a money. You need a time. So that's what I'm trying to explain you. So think from an entire perspective, not only one. Technology, you're correct.
Yeah.
I'm not denying that. The discussion is happening. Not to talk. We're talking about which technology is good, which platform is good, right? So vis-a-vis, you have to look after the
Yes.
license, expenses, everything. We'll talk about it later. Is that okay,
All
Prasanna?
right, all right.
Thank
So
you.
yeah, sorry for diverting.
No, that's fine. That's fine. It's fine. As long as you guys are being okay. Thank you very much. So yes, Prasanna has some point, which is little valid, but not all of them. So you have to look into in the aspect of storage in terms of technology, the expenses, licenses. So if you can see that the previous example which Sears had earlier, let me go back a little bit and talk about. So we had the same issues, right? You already have everything here. So they got everything done, but they have still an issue. Okay. Coming back to that, so then we have an ETL compute grid. So when you talk about loading data from one to another, you need to do an ETL and you have to move from one network to another is always be a challenge. Now you can see a merge of 20% of data. So let me have this little bit. Yeah, yeah. So if you talk about this, right, we're saying uh, we're doing a kind of a 10% of data of 2 petabytes or zettabytes data, which is for an aggregation. So we are saying we had aggregated those data according because we don't have a problem. We have size issues, we have a memory issues, we have a RAM issues. So we'll say, okay, let's go for an aggregate data. So we are not talking about a detailed data. So your 10% data is your detailed data. Sorry, the aggregate data. So all your data is not there. Still it's there, you cannot do the kind of a reporting. And then top of that, you have a BI reporting and interactive applications. So those are definitely talking to your current environment. So this is because of vertical scaling, you are failed to do that. So your hard disk, right? Your hard disk, your CPU, right? And you're definitely a kind of a RAM. So This all three, we actually go ahead and do the increment, but at certain limitation you find, okay, this is not true. We cannot go beyond the limit. So that was actually we talking about a kind of traditional system. So if you talk about any traditional system today, it's you have to have your database in underlying. So now let's go and see how it's happening in horizontally. If you go and the same process, if you go by horizontal, see that. Now congestion is not an issue. I mean, you have ingestion to taking out all the data from different places. So if you talk about you have a different sources, multiple sources, wherever you talk about, the collection of data is basically not stopping you, as it is not centralized. So you have to understand it is not centralized. In the previous section, it was a centralized one. Now here we have a distribution environment. So wherever you take data, wherever you put in. So there's not an issue in terms of the data taking data. That's called data injection. So we are injecting data from different places. We are collecting data, and because of see that we have a Hadoop storage, right? Then you also have a compute grid. So we'll talk about little later. We have a master slave and data node and so on. So we'll talk about an architecture a bit later. Just to have, they have something called multiple computers joining to one. So how Hadoop comes up is horizontal scaling. We'll talk about a little from now on. And even we talk about, let me see what is the next so that we can talk about on this. Give me a second. What is the next topic we'll talk about? Yes, we are actually about to talk about bit. So what we're trying to do is we are saying because of Hadoop, the storage is not an issue. So forget about that. We are not even looking into. All right. So the number one, data exploration and analytics, advanced analytics can be done because you have all your data. No data archiving. See that? Keeping data alive forever. So this is, you're not keeping a dead, because when you go for the premature death, because your all data was not there at one place. So if you say I want to do the analysis of 20 years and 30 years, sorry, traditionally you cannot do that, right? So it is important to keep all your data. Okay, Supriya says, I'm a beginner. Could you please be basic because I could get your terminology? Okay, Supriya, do let me know what exactly you're looking for. Which terminology? Can I help you on that? So when I talk about, getting something here, we are still talking about the basics. So when you say no archiving data, do you understand the archiving? If not, I'm going to help you. So archiving, we have data which is already stored for a while and number of years. So I give you a small example and we can go through it. So give me 1 minute. So if you have 100 GB data, right, and your capacity, or maybe you have 200 capacity of your database, so you also go and add one more 100 GB data, right, and you are good to go. You're done. Your 2 GB is finished. You cannot use it again. So what you do, either you increase it, right, again 100 GB, or you then archive the data and take it out and keep it in your some tape, maybe Sony tape, a cartridge, right, so that you can free out your 200 GB data. So this is called archiving. So still the whole entire of data, you can't do that. The old data is there in your tape and the new data is available at your database live. So the capacity here is not possible. Okay, so Priya is saying what is the collection? I didn't understand another steps. Collection is taking data from different places to one, right? You integrate data at one place. So collection, so you can do the injection from anywhere, from flat file to your, different data like Facebook, Twitter, or you have your log files. So collection, you collecting those data. So when you inject them by technology, then you collect data and put it at some place. So that's called collection. It is a process of data insertion. Does it make sense? If not, please help me out. I'm gonna be talk about a bit more. Thank you very much, Supriya. Karnan saying it is possible to tape storage data move into Hadoop. The answer is yes. You can take out all the data and slowly you can pumping them. This is what is happening now. There's a lot of people doing a migration. That's called migration. the existing data, whether it's the tape or it has to come back to a kind of a database. Tape directly cannot be accessed. It's a sequential access with the tape. So you may have to insert back to your some database and then you have to load it. So there would be structural concepts. Does it answer your question, Kannan? Did you understand what I'm saying? Just give me yes or no. Thank you very much. Good. So as I said, you have to have the third scalable third and for ETL and aggregation. So you have a data and you've been quite being scalable on that. Prasanna says, is this the way to place archive only for read? Exactly not, Prasanna. It is a cartridge you store into and you cannot read cartridge. It reads only once. You either read one or you can only write, definitely write one and read many times, but it runs once the cartridge starts, it has to finish it. So it's like a cassette. You must have seen older days when you go for music cassettes. It's a kind of a cartridge. It's a magnetic tape where you store all your information. Okay, does it answer your question, Prasanna? Okay, fine. Makes sense. So, having said that, the most important part what we're doing is, so you guys have to understand the most important aspect here is we're trying to get a big data Hadoop platform, make you understand why we came to big data Hadoop. What is the reason behind? There should be challenges coming in. Why do we do that? Yes, then you load the Hadoop. That's Prasanna saying, then the load to Hadoop. Prasanna, very important. You have a cartridge, you have to read them, put it at one place, and then you can put it to Hadoop. Okay. Coming back to that, so archiving is fine. See that data available, all petabyte data is available for your processing. Both storage and processing is faster, right? As usual, RDBMS, you can have an aggregate data, you can push back to RDBMS. So I have a question here, guys. Why are we saying RDBMS aggregate data? Who can explain back? That's the very important aspects. Anybody? Why are we saying the RDBMS? Right? Here again, I'm saying RDBMS. Here I'm saying again RDBMS. Why are we saying RDBMS? Yes, I got one very good answer from Abdul saying that summarize data reports. BI can't run Hadoop. No, Amit, BI can run Hadoop. Don't worry. That's what the BI being made for. Like Tableau, OBI, everywhere they can connect directly to Hadoop. Don't worry. Madhvi says structured data. It would be efficient to do analytics on RDBMS versus going straight forward. Jitesh, no. The answer is no. Okay. HBase. Okay. So I get a lot of answers. Guys, to make you understand, when you say aggregated data is actually either you're going by a storage in a cube or you're going for a kind of analysis data. So when you say aggregate data, it's actually summary data and where you want to keep those summary. So Hadoop is definitely has a file system. To be very honest, Hadoop does not has Oracle or some database. HBase is there, we'll talk about little later, but again Hadoop at the bottom level they have the flat file. So any RDBMS or any database or any kind of a NoSQL database like HBase, they need some kind of a structural format to really run the aggregated form. So if you talk about a file data, has every file cannot be proper as kind of a RDBMS. You cannot perform any function over the file. Either put an HBase, you put Cassandra, you put a kind of some bigger MySQL Oracle kind of stuff. So what you're saying, can you see this? I'm saying you're pushing back to your RDBMS. So what is this? That's my question. Why are you saying pushing back? That's my question. So if you're pushing go back, what is it doing is your data exploration and advanced analytics is happening, right? You're not doing any archiving. So RDBMS, you can read the data, pushing into your Hadoop analysis. Yes, I think Ananta saying calculation and faster reporting. So the idea was you getting everything here in Hadoop, you do the processing with the Hadoop, and then the summarized data, the final data, you can push back to your RDBMS if you wish. Having said that, this BI report can directly connect to your Hadoop to run that, right? But the methodology people have been used in a couple of years. Traditionally, people for that example, we had a discussion with Prasanna. He's trying to put everything in Cube and put into the reporting, right? So there are people, not only me and Prasanna, everybody who we come from the start from a career. We've been going for database, warehouse, BI, and then the big data. So we're trying to definitely get the same structure. So this is what you can have your data coming in your RDBMS going to your Hadoop. So for example, you got a MySQL here, right? MySQL data, you put it here, do the analysis, do the analytics, and then you can put it back, the RDBMS. You can put it back again here. And then out of this, you can go for a reporting. So at time you have a structure where you can say, okay, do all these stuffs, put it in Hadoop, and then you need a reporting database or some platform to do that. But still, when you're going for reporting, you do not, if you're saying going at aggregated data, you're again restricting, but you may have aggregated for all the data. Okay, Supriya is saying, what is BI stand for? BI stand for Business Intelligence, Supriya. So if you can give me your background, Supriya, will be better, because I can think that all the basics of the terminology being, having some issue here. So you let me know what is ETL, what is BI. Do you really understand this? So pressing after processing the data, put the ETL into RDBMS using ETL. Yes, ETL is extract, transform, and load is a data population process. It's called data integration, right? So it is important to understand the BI. BI is business intelligence. Jitesh says, are we saying if it is not efficient to do analytics going through straight Hadoops, that's the reason why we are having aggregated? No, Jitesh, this is not the case. So let me, have a small discussion here. Jitesh, can you hear me?
Yeah.
Okay, good. So what is the question? What is the, can I explain you that? So why we put it in aggregated data? That's what the question is. Is it correct?
Right. So
okay.
Trying to understand why would we not go straight?
Can you come to your mic, Jitesh? I'm not able to hear you much.
Yeah, can you hear me now?
Now it's much better. Please go ahead.
Okay. Yeah. So I'm trying to understand why we cannot go straight to Hadoop to do any analytics. Why we have to go to RDBMS?
Okay.
Is that efficiency the factor, or what's the reason?
No. So you can see that I have drawn a picture from BI reporting interactive tool directly to Hadoop. So today, if you talk about 2017, so let me tell you, there's BI infrastructure is already ready. Do you understand that? The infrastructure, BI project architecture, everything is ready, right? And you want to implement the Hadoop. Make sense?
Okay.
So here you have RDBMS, your ETL, your reporting tool like Tableau is already there, right? Now,
Right.
you want your data, put it in Hadoop. Hadoop is basically used for two things, your storage and processing. Am I correct? Now,
Right.
when I do a BI, traditionally using any Oracle database, and you're putting the data and doing analysis, ETL is done, and then reporting is done. That's what the architecture you follow, right? But
Right.
that's a limitation here. At certain days and vertical scaling, you can't do that. So what I'm saying is, if you want to use existing architecture, right, and only this part, storage and capacity, the processing part, put it in Hadoop, and you want to still the same architecture altogether. Because see, changing a complete platform would be always be accessibility. There would be a kind of a cause. There would be a limitations again. You may not go in complete change. So Hadoop setup, it can be used only for two things. For there's something called data migration project. If you talk about today, a lot of Hadoop is the migration project. People do not start scratch from Hadoop, right? So now when I say RDBMS is an aggregated data, it is an option. It is not mandate. Let me tell you, it is an option where you can read RDBMS, right, and write back to RDBMS. Did you understand what I'm saying? So you can push back your data in Hadoop, do the analysis, and push, you can get it to RDBMS once again, the aggregate data.
Right. So there can be, like, let's say, in a scenario where I am building data warehouse from scratch.
Correct.
right? So using Hadoop. So in that
Correct.
scenario, I don't have to worry about
No,
having
exactly.
data
This is not
physical to
needed. This is
RDBMS.
not needed. So I said this anything you talk about today, Tableau, you talk about OBI, you talk about MSBI, you talk about ClickView, you talk about Cognos, anything and everything today is directly connecting to this Hadoop. So they have either Apache. Apache is the organization, which is open source. We'll talk about a little later. They have a driver, or then, for example, if you talk about Tableau, Tableau have its own driver to connect with Cloudera, with Hortonworks, with Mapper, right? So these all we're talking about in terms of if you don't need them at all. So this important is you have to completely understand where we're talking about. So there's when I say aggregated data, so you already have 2 petabyte data which is available, right? But you want all aggregated data here. But I'm not saying it is confirmed. See this, I'm saying all the data, nothing you're taking, no archiving coming in, your data is not even dead, it's alive, right?
Right.
Now whenever
Right.
you want, you can push back again. But in the previous section, do you have a data? The answer is no, you don't have a data, you cannot push back. So it's like you have all the data, all the food on one plate, you're taking on a small plate, only few food, and you want to eat, you eat it. If you want more food, you grab again. Am I clear what I'm trying to explain you?
Yeah, I'm good. I got it.
Okay.
Thank you.
Thank you very much, Jitesh. Fine, guys. So that was, Jitesh, and we have spoken about the RDBMS. So there would be and the chance where you want to just keep RDBMS ready and you want to use the RDBMS. So there's a Hadoop. It says you can have, get your data from RDBMS and push back the aggregated data to your RDBMS. That's all, right? It's nothing, no recommendation. It's not mandate that you can use it. So BI is a business intelligence which talks about a reporting. So you can take out your reports directly from Hadoop. That's what the new development is taking place. Any further question here, guys? A solution, a combined storage of computing. So we'll talk about why we're saying Hadoop as a storage, and then we'll have it here. The next level of discussions, we talk about horizontal scaling. Is that clear, guys? Am I have any confirmation, please? Okay, Anubhuti says yes. Prasanna says okay. Prasanna says question mark. Prasanna, can we be more explanatory? Karthik says Hadoop does support update, delete, and just support insert. Yeah, I think Karthik, you just please wait for a minute. The Hadoop will not talk about an OLTP the way it does. It's always be loading the data. We'll talk about it later in detail, right? Okay, Prasanna says Hadoop is a structured or unstructured data. Hadoop is a combination of structured, unstructured, and semi-structured. Scaling. So Ganesh has an issue with the scaling. Okay, fine. So let me have small discussion. Ganesh, can you hear me? Is your mic working, Ganesh? If you can hear me, can you just be unmuted yourself?
Oh yeah, can you hear me?
Yes, I can hear you. So you have a question on scaling, isn't it?
Yeah, so basically, initially we talked about Hadoop stands for both the three things, right? That was CPU,
Your voice is
storage.
a little slow, Ganesh. I'm not able to hear you. Can you just come to your mic, please?
Okay, yeah,
Now,
sorry, yeah.
yes, it's fine.
So
Please.
initially, yeah, okay.
Mhm.
Initially, when you talked about Hadoop, we talked that it helps on both storage, processing, and RAM, right?
Mhm.
Now here we are. It looks like we are focusing only on the storage part and the processing and the RAM part. I don't know. We are not covering that. Like so,
Processing is
is
not
it?
covered. So see that
And
2 petabyte data is available for your processing. All your data. You're not even taking archiving. See that here in the section of third. Keep data
okay,
alive forever. How about the data explorer and advanced analytics? So what is data exploration and advanced
okay,
analytics? This is processing only, right?
okay,
So
okay,
see that both the storage and processing. So here we'll talk about in the next slide how this horizontal scaling is happening. Then you probably get to know more. So here We are saying
Okay.
we came across from the vertical scaling. We are finished. We are no more using the vertical scaling. We are going for horizontal scaling. How Hadoop solves this issue, storage and processing, definitely we'll talk about after the break.
Okay.
You
Fine.
understand? So you understand the
Yeah.
vertical scaling? Yes or no? Yesterday's discussion. That's my point.
Yeah. Yeah.
That
I understand.
okay. If you understand that, you will be able to understand the next one as well. Make sense?
Okay.
Okay.
Yeah.
Thank you very much. Guys, if you can permit us, can we have a small break here for 5 minutes? Need to go and grab some coffee and come back. Okay, you guys can take a break, and I hope things are going and you guys are appreciating would be the concepts. Do let me know where I can help you more. And Supriya is asking how do you compute data in Hadoop? Supriya, just park this question for a while. We'll do that later. So keep this question when the Hadoop stuff comes up. You will definitely ask this question. Thank you very much, guys. Stay tuned and we'll come back after 5 minutes. Thank you. Guys, I'm back. Let me know if you guys are there. Good, Persona is here. Good. Thank you. Okay. So I hope people are back. I believe. If not, they'll definitely joining in shortly. So guys, we're good to go from the point of view of understanding. We will have to just speed up because we have to cover the course as well. So restrict your limitation and restrict your discussion at the point and be focused on the topic so that it can help us everybody to achieve the goal. Okay, so why DFS? We'll talk about more, distributed file system. Now here we'll have a question and answer session, a small one, and we'll talk about how the horizontal is being happening. So is everybody is there? Then probably I can start. If you guys can permit me, can I start? Okay. So Supra is saying your explanation is not clear about fraud detection. Could you please explain me again? Amit says which technology does the streaming analytics? Amit, just wait for the streaming. It's basically Flume, Kafka, and definitely Spark. We'll talk about it a little later. To answer Supriya, Supriya, when you say fraud detection, you have your data to do the analysis upon that. So when I say a live, if somebody have used a credit card here and after 10 minutes you use a different geography, so they're taking data in every intervals, maybe 1 minute or so, and they can do the analysis, and that's how the fraud being getting detected. All right. So keep it straightforward and simple. Don't get into much into what is happening and how it's happening at this stage. You would be actually confused rather than getting an answer. Right. So I would say because of initial 1 or 2 classes, keep concentrate. I know a lot of question will come to you and you'll probably able to, not get the answer at this stage, but please keep everything, I would suggest wait and watch, see how things going on and moving across, you'll get your answers. There will be some question I can answer now. There will be some question I will be ask you to park. So please don't mind my apology because of the time of interest of time as well as the, concept. We are not talking about the same. Right. So we'll talk about one question, guys. So there's one machine you can see here. It says, okay, I got one machine and multiple machine at the same time. So one machine, and you can see that is saying 4 channels and then your 100 Mbps each channel speed and the processing. So reading 1 TB data by one system and reading 1 TB system by 10 machine. So if let's say if it's taking 40 minutes at one machine, what do you think it take with the next machine? When I go for 10 machines and when I go for a single machine, this is one machine and this is 10 machine, guys. So can you tell me if it is 40 minutes with one machine, how much time it should take for 10 machines? Straightforward answer. People says 4 minutes. That's great. Good. So you guys understood when I say 4 minutes, how the 4 minutes happening, all right? How does 4 minute, how did you understand this 4 minute taking and how it would be taking in? So the most important part would be when I say 4 minutes, that means you shared your work, you shared your all your work to a multiple PC, right? So when you talk about this here, you have a multiple PC vis-a-vis you got a single PC. Now let me talk about how the horizontal, scaling is work. This is the horizontal scaling. Now we are not using for one PC, we have a multiple PC. So that's what Hadoop comes from, and that's what Hadoop is being using in. So what Hadoop does it? So let me talk about Hadoop specific. So guys, you put your question only against this horizontal scaling. Please keep it, very simple and short. So you're saying horizontal, so something like horizon. I'm talking about horizontally. You're actually increasing, or horizontally you're actually moving your scaling. So this horizontal scaling, what is happening? You have one system earlier in the vertical scaling, and you keep increasing CPU, RAM, and definitely what is your hard disk drive. Now here, because of single system, you do this. What I do in Hadoop, we do not go and increase in single system. We actually brought a couple of systems. So rather than one system, we brought 10 systems. And now I will talk about 10 systems. Then you must be thinking the cost. Why the 10 system? The number one. So people says the cost would be definitely higher when you're going for one system than how the other system. So Supriya is saying work is shared between the 10 system, right? Thank you, Supriya. So when it comes to the horizontal scaling, first of all, Hadoop, if you talk about, they use commodity hardware. So commodity hardware is basically, it's a local vendor hardware, right? It's local vendor means they do not need IBM server, they do not need, going further, they do not need a kind of a Oracle server and so on. So it's actually, they're saying they look for all the normal PC or a laptop or some sort of, kind of a desktop, which is a normal configuration, and even a kind of a assembled PC or a local PC can work as an Hadoop cluster. So they need a normal community hardware. They don't need a highly licensed server. And so that if you can have this 10 systems horizontally, so you can see that one system, now you got a 10 different systems and have a local hardware, local vendor, and also a less configuration. Okay, so less configuration means you don't need a higher configuration. So whatever it has one configuration, let's say, whatever you decided for 100 GB or some hard disk and some RAM, keep everything the same for the other 10 pieces. So you can see the number one, you are storing, right? This storing all your data, right? You got a multiple what? Multiple systems. So it is horizontally, it is not talking about a vertical change. Now it's saying a horizontal change. So it has one, now it has a multiple, let's say 10. So it's in this Hadoop concept, when you go a little further, we'll talk about, they call up Hadoop, they say Hadoop cluster, right? The single cluster, when it's a single cluster, can have multiple nodes. So we'll talk about a little more when we go a little further. So just keep in mind here in this time, when I say horizontal one, so we're saying we're having one machine. Now you got a 10 machine to run the 1 TB date time. It takes 10 times lesser. So 43 minutes here, definitely going to take it 4.3 minutes here. So that's the difference when you talk about horizontal scaling. So is it clear, guys? All the guys are clear what is vertical scaling and what is horizontal scaling? Can I quickly get a confirmation if you understood horizontal and vertical scaling? If you have somebody ask, or somebody, if you want to explain somebody, this is what it is. Good, thank you very much. Fine. So horizontal scaling is the multiple PC, multiple systems, whereas the vertical scaling is the same system and increasing their CPU, RAM, and storage. Well, now we are coming to the actual class where we talk about a Hadoop. So first of all, Hadoop, when you talk about Apache Hadoop, Apache is the organization which is giving all project free of freeware or free of cost, and openware, whatever we call. So they're not charging you anything. They are actually having an organization. They gives all project free of cost. Karan saying horizontal scaling number of machine, how we can connect one cluster. Okay, Karan, Karan, just wait for this question. We're gonna come back again. So we'll have that. So you'll be getting this answer soon when you go for consecutive slides, and we'll get to know that. Just please park this, question right now. Thank you. So Hadoop is a framework. Now let me tell you, Hadoop is not a technology. Please correct yourself. If somebody has says Hadoop is a technology, Hadoop is a concept. I would remember saying somebody said, okay, Hadoop is a technology, let's use it. So Hadoop can be a concept based on some framework. Now somebody can answer me, Hadoop based on what framework? Anybody has understand? Anybody knows that? It is a basic question. Hadoop based on what framework? What is a framework? Can somebody tell me? Yes, I got a very good answer from Amit. Anybody else? I'm expecting so that I can, come to the answer. Amit, can you hear me? Amit, can you hear me?
Yes, I can hear you.
Okay, good. So you given an answer. Can you just explore one more minute? Will that be fine?
Yeah.
Okay, go ahead, shoot it.
Yeah, I'm fine.
It is based on Java, right?
So, Java, right. So
Correct?
all the classes in Hadoop and all the libraries, I believe, are written in Java, right?
Okay, from the base Hadoop, Apache Hadoop, yes. So coming, you can also integrate something else like Python or anything. Also, you can use it later on. But the base is actually coming from a Java. Thank you very much, Amit.
Thank you.
So guys, the framework is actually Java. Hadoop is built on Java, top of your Java. So different the structure, if you see the main class or base class or all the packages imported is actually treated in Java. All right. So Hadoop is a framework that allows you distributed processing for large data set across the clusters of commodity computer using a simple programming model. Can you see that commodity computers has come up? All right. So Supriya is asking whose library are written in Java? Or can you be clear question with Supriya or saying whose library? Hadoop is a framework and their library be written in Java. Is it answer your question? Okay, fine. So first of all, it's an open source. You don't have to pay for that if you're using a vanilla implementation. So you can simply download and definitely use them up. Okay, Supriya Singh, I was answering your previous question on Hadoop. Okay, fine. Thank you very much, Supriya. It's my mistake. Apology. So yes, it's an open source. You don't have to pay about the basic code. You can still take your codes and you can use the same, and that's using for this view all for your distributed environment. Right. So Hadoop is a kind of a platform, and it's an open source, and it's a Java based on Java framework. So these three things are very important. Okay. Hadoop key characteristics. Hadoop features reliable, flexible, economical, and scalable. So I hope by the time now you understand what we're trying to understand, right? So when I say reliable, yes, it is reliable because you're not depending on kind of any failure. We'll talk about it a little later. So these are just basics. Keep it in a first simple class, just understanding, okay, these are the words and this is the mean, and we'll come to the actual understanding of your concepts will be more deeper. So reliable you can trust upon because it's not get failure. If it get failure, it being procured itself. We'll talk about how and when later on. Economical because it is not based on this server of high end to buy an IBM server and an Oracle server, a bigger one. It's a commodity hardware. So you can buying a normal PC from outside in a normal computer market, which is assembled, it still can be used. Scalable, you see that is the horizontal scaling you already understood. So if you think that system is being not working and storage capacity is lesser, you add one more system, very good to go. Your cluster can be keep adding it. Flexible. So definitely it's more flexible. Just to have a small introduction of the concepts of multiple scalable and flexible is if you have multiple nodes, which is somewhere around 100 and 150, it can be flexible. You can have your data from one to another place. It's not fixed at one place. It can be going with any nodes, and according to that node address, you can take your data back. Scalable Just to give you an idea, Hadoop is the one who started, Yahoo is the one who started Hadoop way back, and they have initiated with 200 nodes and they found everything perfectly fine. So they have already trusted and tested 200 to 300 nodes altogether. Fine. So that was we talking about more from the understanding point of view. So Hadoop design principles, structured and unstructured data, simple programming mode. So Hadoop stands for two things. That's one is a storage, second is processing. So just keep remember. Hadoop says HDFS, which is storage, MapReduce is the processing. We'll talk about soon. Scale out rather than scale up. So definitely you're not scaling up your vertical, you scale out. So definitely you're going for horizontal scaling, which you already saw. Bring code to data rather than data to code. So let me tell you, when you have a multiple, if you talk about traditionally what you do, you centralize your data, you go and read the data and then you process. Now here, what is saying, if you have a clusters of 100 node, let's say for example, 10 nodes, you do not go and get the data and then you do programming. So programs runs on your data, wherever data it is. If it is 10 node, it runs program in 10 nodes. So it is more faster. So if you say bring code to data rather than data to code, is it clear, guys? Karan saying which level security available Hadoop? Karan, can you keep this question aside at this stage, because you guys are talking about little deeper and I would not able to explain you at this stage, and we are far about from the normal speed. So let's finish the basics first and then get to all your bigger question like security, everything. So let's learn Hadoop first, then you talk about high end questions. How security is taking place. Yes, there would be processes are there. So I would request, please keep your questions more towards the current one. The topic which we're talking about, let's focus here. How Hadoop is installed, how cluster is working, how they're connected, how's the security. This is not, we're not talking here. So I would request, please keep your question more focused about topic. Otherwise you lose your content on your initial basics and you will not able to do it again, right? Yes, I'm saying it is one of the feature, right, Kanan? But let's talk about little later. So security is not we're talking about here. It is flexible, yes. So we've just talked about, we'll go one by one and then we look into more detail. So I would request, I'm not denying your question, but keeping an interest of the 2 hours time. 2 hours are pretty less time, right? So first 5 minutes we're waiting for the people, and then we take a 5 minutes break. 10-15 minutes is already gone. So please, I would request, keep your question towards that. I'll be happy to help you. At rest, you just take the time to come up. It's only a second class of Hadoop, and the other people also there. The 25 people, 26 people are there. I would request, please keep it in the topic specific. Thank you very much. Apologize if you take it hard. Okay, Hadoop design patterns. We're talking about what is we've spoken bring code to data rather than code to data to code. That's the question. Is everybody's understood? Right? Anubhuti says no. Good. So Anubhuti, can you hear me?
Yes, Indra.
Okay, so when I say bring program to code, so if you can see what it says is bring code to data rather than data to code. Code is program actually. So if I ask you,
Mm,
normally what happen if you say there's one system, right? One database,
yes.
right? So when you say, okay, I want to do sum salary plus commission, simple example, what do? You write a
Mm,
program,
yes.
right? The program takes the
Yes.
data from database, it reads from where?
Yes.
Reads from DB, and then then the
Yes.
performing
Table.
calculation, right?
Yes.
So you're
Yes.
what you're doing, you're calling data into program.
Yes.
Am I correct?
Into a program. Yes.
Now Hadoop does not work that way. It's vice versa. So if it is
Okay.
10 systems which data is lying, right?
Mm-hmm.
Hadoop go
Mm-hmm.
and replicate. Replicate, you understand? I mean duplicate. That's the other word.
Yes. Yes. Mm-hmm.
10 programs, same programs.
Mm-hmm.
It does not go and store those programs, but they are run into the memory and they go with the data here. So each system run the program. So despite calling the database into the program, they're saying let's go the program at the data wherever it's storing. So if the program running on your in your system, for example, you got one laptop, you're running it, right? If you're reading data from other system, then you have to retrieve your data first into the program, then you perform. Now here, I'm saying don't go and take the data. Take your program and keep it in the data. So wherever a database there, you run it there. Will it be faster? Yes or no?
Yes, it will be.
Okay.
It will
So
be.
it's like Ganesh is saying sending logistic to computers, almost quite similar, Ganesh. So what I'm saying is it says bring code to data rather than data to code. You got my point? Here
Yes, means okay.
you're actually taking your program and you taking data to your program, which is code. Now here I'm saying no, I don't want to get into, I don't want to retrieve the data from database and then the program runs. I want wherever data is there, run my program. Is it make sense? Did you really clear with that?
Yes, now I'm clear with
Yeah,
that.
thank you very much.
Thank you.
Okay, good. So Vivor says does there only one system does processing at a time instead of all machine cluster? All cluster runs Vivor. We'll talk about how this strategy works. There's a node and there's we'll talk about little later, one or two session. We'll get to know how it happening. But retrieve data in 10 systems and computer right. Ananda says okay. Supriya says yes, that's wonderful thought program of data. Good, thank you very much. So guys, keep your questions a little intact. I think they're question for cluster. So wait for 2 more minutes. We are actually getting into that position and we'll able to answer this soon. Keep your question ready so that I can answer you back. High scalable and availability, because you have scalability, you can scale that. Availability gonna be available all your servers, right? User hardware and commodity. Now how the availability comes with the fault tolerance. So what is fault tolerance? Is anybody understand that? I'll quickly gonna give you an answer. Is like when you have fault tolerance, if it is a 10 system, if one fails, 9 is still active, right? And because Hadoop works on replica concept, we'll talk about later. So it is a copy of 3 of data. So actually you do not lose the data, and that's what the fault tolerance help you up. So these concepts will come in more in detail. So keep your thoughts ready so that you can talk about a bit more, right? So these are design pattern of your Hadoop, how it really works. Okay, good understanding. So RDBMS versus Hadoop. A lot of people have already done. You know that what is RDBMS and how the RDBMS is acting. So one particular answer which I would be able to help you, one particular thought. So to be one answer, you have schema on RDBMS on write, right? Whereas Hadoop is schema on read. So when you have here, you talk about structured data, right? Anything you talk about on RDBMS is structured data. If you talk about anything you have in a normal table and you want to put the data, it has to be structured, right? So when you do, for example, if I write create table, right? So create table, if I'm let's say I'm taking employee table, right? And I'm saying, okay, talk about employee ID, which is, number. And I'm saying take only one thing is employee name, right? Is your varchar, for example. Fine. And the salary. So if I enter a data, I need to enter, first of all, say insert into your table, whatever table you are using. So we have insert into the table is employee for that matter, right? And I'm saying the values which I want to enter is your employee is one, quotes is, just say, let's say Hadoop for that matter. And then we talk about a kind of a data is salary is $2,000. So don't you think this is complete structured? Number one, when I just take out one quote, so what happens? Can you just tell me what happens if I take out one quote, or let's say remove both of the quotes? Does my data inserts into the schema? Do you think so? The answer is no. Why? Why it cannot insert the data? Because it has, yes, a string. Okay, that's you talking about data type. I was talking about methodology, not the data type. The schema on write. So whenever you say schema on write, whenever you're writing something, it go and find out the schema. It does not worry about, okay, it is not reading, it is writing. If it is not validated proper with a string or character or whatever data type you have, right, you would not able to insert. So idea is not that I've taken out a string. Yes, I've taken out a string, but the taking out string is not the concept. Is that means it validates the data. First of all, it validates, then only it let you insert into the table. So that means the schema on write. Now when you go and write anything in Hadoop, it does not even looking into your writing is like number, or you're writing at in a string, they does not have a validation at all, right? So please do not worry. While schema on write is not at all worry, you take any data, you put a blank data, right? A blank record. You've seen you know, one of the example, veracity, where you seen that null value can also be get it into. It is important to understand that, okay, we are saying schema on read, not in schema on write. So that's what Hadoop comes across, right? Structured limited no data processing point of view. So processing couple of data here in the Hadoop. Here you have a structured data type. Here's a talk about multi and unstructured. So here you can have not specific data types available. Okay, it's not like a database where you have a string or a type or other stuff is available. It is based on your three structure, which is structured, semi-structured, and unstructured of data. So it's not schema on write, it's schema on read. So that's what we're talking about. Structured and definitely standard governance. Now here it is loosely structured, because we don't say, okay, don't check out a space, it should be validated, the age should be this with this, the salary has to be always positive values. No, it is not, because it's not structured, it is not a schema on write. So that's the reason it's being pretty, I would say it's not the way it is being in the database we're working here. You see here, schema on write and required on read. So this is required on write, required on read. So schema on write, schema on read. You can see this is what I was talking about. It is most important. So Amit says, can you explain schema on read? So when schema on read is basically you are only reading. When you're reading anything, while writing you're not worried. While reading, you can say, okay, what data you're reading. While you're reading, you can do the validation. It is still says you can read anything, even a blank record, but you can validate. Say, okay, I don't want to read a blank record. So schema on read, you can put validation, right? But here, when you say schema on write, it is already validated by structure. You don't have to worry, and it will fail if it is not governed. Okay, reads and fast speed, write and fast. So here we're talking about a reading, right? Here you're saying a write. So where you talk about an RDBMS, you read the data or structured data, right? It's going to be faster. Now here Hadoop, it's not about reading. Definitely processing is important factor Hadoop has, because the data is huge. There's an opportunity how do we make it fast. But normally it is being more for writing. You're taking all your data. That's the more purpose. Now here, if you talk about cost wise, support license, software license is being what? So here you pay all your software license for Oracle or anywhere database vendors you have. Where here every code is coming free. Now when you say free, it is not free. When you talk about a Cloudera, Mapper, Huttonworks, any software which is coming free, you would not go for production. You need somebody who can do a testing and give it to you, saying that, okay, look, this is tested, you go ahead and do something. Any failure comes, we are responsible. You pay us only the support, not for the product. So Cloudera, Mapar, Huttonworks, they are actually selling your support license, not the product license, because they have a product which is being already using Apache, but they give you only a support. That's what they get paid for it. Resources, known entity here, because of the growing complexities and wide variety, volume, velocity, and variety and veracity. We don't have any resources fixed. It can be expanding. That's what we're talking about. Now OLTP is basically action, kind of AC transactions, operational data stored. Best fit when you talk about operations. Now here is a data discovery. So definitely it's Hadoop is actually Hadoop analytics, just to let you one word, right? A lot of people says Hadoop database. That's wrong terminology. Hadoop cannot be a database. Hadoop, it is the analytics. So when you say Hadoop, Big data analytics, that's normal people call it big data Hadoop, big data analytics. So that's the terminology, that's the right terminology. Big data storage, big data database, it's not the right pronunciation and right store, I mean kind of a terminology. So anything operations, you go for a database. Then anything is kind of analytics, so you go for Hadoop. So I have one question, guys. Does that mean the RDBMS does not require at all? Can I get the answer? Amit says no, OLTP. Karan says yes, required. It is required for structured data. Supriya says no. Pretty fine. Thank you very much. So thank you for this response. I think you guys understood. That's the reason I wanted to ask this question. Okay. So small question. Annie is very intelligent lady. She wants to understand more. So Hadoop is a framework that allows the distributed processing of. Can I get this answer? Large data set. Okay, good. So that should be the answer. Okay, good. All right. So it is a capable of processing a small data set. However, to experience true power of Hadoop, one needs to have data in terabytes, because the where the RDBMS takes are and fails where Hadoop does the same couple of minutes. Good. So you guys have been understanding pretty well. Thank you very much. So now we're coming to the Hadoop, ecosystem rather. So is that okay to continue? You guys, any questions so far? So we just wanted to finish this, if you guys are okay so far. Am I too fast? Do let me know. If not, I'm just parking some of the question which is not being relevant too much here. I would apologize. Don't take me wrong. I would like you to really come and put the specific slides and concepts clear at this stage. I know there are a lot of questions there in your mind, so keep this question. I would say this is good. I like it. It's lovely. I'm loving it when you're asking a question, but does not make sense at this stage. So keep your questions ready. We're gonna come back soon. It's just starting, guys. So yes, long to go. I had a question regarding code to data. So yes, Prasanna, go ahead if you have a question. So you can just tell me what is the question you have, so that probably we can discuss on that quickly. I can help you in that. Yes, Prasanna, go ahead.
Yeah. Hello.
Yeah, go ahead.
Can you? Yes, Indra. You were explaining like code to data versus data to code.
Mm-hmm.
I had a question there, like as because you have taken an example of summation and all,
Mm-hmm.
but my question is, while you will be doing a max of, min of, ranking, or
Mm-hmm.
like that kind of functions,
Mm-hmm.
then like distributed systems should definitely require all the data to be collected and get it to one particular system from where like you will get the max of it or something like that. I mean, you are understanding, right, what I'm trying to
Okay.
say you.
I understand what the question is. So I would say keep your question ready. Let me have my ecosystem and HDFS as the architecture, because your question is still lying. Once you know the architecture, your question get answered automatically. How the performance
All right.
happening within the cluster. You wanted to know how
Mhm.
things are happening, right? If you know how the cluster is doing computation, you'll get your answer. So keep this question ready. I understand what you're talking about. So
All right.
in my thought, what I said is earlier we used to call the data in your program. Now what I'm saying, you go the data and program run there. Now how do we do that? We'll tell you in this short story soon, right?
Okay.
Okay. Amit says, can we implement a Hadoop in production on overnight batch or a report daily transaction, or it is good only for decision making analysis? Amit, his answer is yes and no, depending what your requirement. For example, Aadhaar card in India, it happens, every 1 hour they populate their data and they put it in your, Aadhaar card repository. Does it answer your question? So the answer is yes and no, depending what you're looking forward. What is your requirement? Make sense? Okay, so let me go back and get back to the position here. So ecosystem. So we have a Hadoop 1 and 2. Hadoop 1 is the latest. The latest with the old version. Hadoop 2 is the latest. Now let me tell you, Hadoop 2 is also getting obsolete soon. Hadoop 3 is on place. There's still beta version. People are still working upon, right? So I think couple of months 3 would be on the market soon. So Hadoop 1, which we initiated, right? This has when you say OZ, just keep your keep your questions ready for a keep it parked for some while. I'll give you one statement what all this, and then we can talk about later. So OZ is a workflow scheduler. So hope you understand. You schedule the data, especially a job. So you schedule job. This is what OZ Apache OZ is being used for. Hive is data warehouse system, which is work as in a Hive SQL, which is quite similar to SQL. Pig is going to be a Latin script, which is being developed by Yahoo and given to Apache, whereas Hive developed by Facebook and given to Apache. Right? You got Matan machine language learning. Then you have a MapReduce program, which and also HBase is in a NoSQL. Here you got SDFS. Now we can talk about little later. Soon you will understand Hadoop distributed file system, how Hadoop is working in, right? Then we say Flume. Anything unstructured or semi-structured data, we load the data, which is like Twitter, Facebook, all your YouTube videos and everything is use a Flume, and which is being stored in your SDFS. And you have your scoop. So scoop is basically a tool which helps any RDBMS data to putting into the Hadoop system and Hadoop system back to RDBMS, right? And definitely you have an Excel sheet you can export to them. Now this is one. If you talk about two, Hadoop 2 has come up with YARN, which is called a yarn, which is yet another resource negotiator. Is kind of acting as a kind of a resource cluster resource management, like an operating system of Hadoop. That's what people call it as of now. Now MapReduce framework is already there. So you can see in Hadoop 2 they have introduced a yarn. So yarn is basically for a resource negotiator. So the purpose of cluster, when you say cluster, you have multiple nodes. You're actually what you're doing, you're gonna manage them. So somebody who has to manage, that's what the yarn comes across. Now you have MapReduce, you have HBase, you got many more framework coming in. You got Spark, and you got Python, Java, other languages. We definitely have a packages to use, and rest it looks quite similar. So only two has come up, which is we talk about what we had as a resource management earlier. Now they have a yarn in Hadoop 2, and we're gonna go for a Hadoop 2, guys. That's for our perspective. So did you understand the overall? Screen is not visible to him. I have a doubt. Kameshwara saying screen is not visible. Am I audible to you, Kameshwara? Guys, I'm audible. You guys can see my screen. Can you just quickly say yes or no? Can you give me a buzz? I got all the yes answer. Okay. So Kameshwara, something wrong with your network. Please log out and log in. Thank you very much. Okay, guys. So machine language with Mahant. So this is actually this basically talk about a Hadoop, one of the package which helps you to learn machine data, and method is actually being using for machine to get into the data in, and you can start working upon. So there would be writing intelligence applications through them, but there are a lot of more coming. Spark is being using more now. This is little absolute, I would say. People are using a Spark machine packages importing, and they have it that. So this was definitely older time. Now people are going more and using a Spark. If you talk about today's environment, so it is there, but people are actually absoluting. The people are going for a new technology. Well, so this is what we talk about. So what is called a storage and processing? Is it the correct one? If I say what is Hadoop, one statement, can somebody tell me what is Hadoop? Okay, one line statement, guys, quickly. Yes, good. Storage plus processing. Good. Thank you, Kameshwar, confirmation. Yes, so we're saying Hadoop is actually combination of storage and processing. So when you say storage and processing, so Prasanna, you are there. You please go ahead and see what we're talking about now. Keep your thoughts ready. So this is how you'll get your answer done. So how Hadoop works, if you talk about core component for storage and processing, they got two different components and they are big different. Okay. Number one, When you say storage, when you're storing something, they call SDFS. H stand for Hadoop, D for distributed, F for file, S for system. So we're saying when you say storage, what is happening is you're talking about, thank you Abdul and thank you everybody for giving me the statement of Hadoop. It's talking about the storage. Now, when SDFS is stored, they got something called name node, data node, and secondary name node. So we'll talk about little later what is these three. So right, we'll talk about something master, which talks about name node, and slave, which talks about data node. Right? This is the storage. If you come right side, it says processing. Yarn is a processing unit. I've told you, right? Is yet that's called yet another resource negotiator. That's the full form of yarn, and is being used for an operating system or resource manager, cluster resource manager, whatever you call it. And they got a resource manager for master and node manager for slave. So we'll talk about more in detail here. So this is storage, guys. To be very honest, we use this for storage, SDFS. We use this for processing. Now here you're going to use a map reduce program, okay, for a processing. So processing is your MR, which is map reduce program, and here you got a SDFS. So SDFS plus MapReduce is becomes Hadoop. Is it clear, guys? If you can allow me, I can proceed further. Okay. So Amit says MR is only option. To get you an answer at this stage, yes, but we have another alternatives as well. So you don't have to worry. But perhaps when it comes to Hadoop, the platform and architecture, everything you write either from Hive or Pig, HBase is actually running MapReduce program at this backend and background. Okay, makes sense. So this is done as of now. Now let's talk about a component, right? So we talk about little more. So we talk about SDFS and yarn you only just had here. You've seen that. So SDFS, guys, file system is storage, and then you have a yarn, which is a processing. So when you talk about, if you can see, this is a main master node, which is a main node. So this is called master. You can see that this is the master one, this is slave one. So it's like you understand this is the main name node and main name node, and then they got all a data node. So they are name nodes and they are data nodes. We'll talk about little later what is name node, what is data node. So when it comes to SDFS cluster, name node and data node comes up, and then each cluster will also have a processing. Remember where I said data program. So you say you go program put on a data. So you see that every data node has a processing unit. No, node manager, node manager, node manager, node manager. They are having it, right? So they have processing in each cluster. We'll talk about little later how it performs. Okay, so now this is more. We'll have to now speak up. Very important that what is name node and what is data node, right? Okay, how many people understand metadata? That's my first question, guys. Before going further, how many people understand metadata? Data about data. I do understand data about data. Good. So I think a lot of people understood. Good. So give you one short and simple answer, not to get confused. Name node is actually a metadata. Okay. Name node is a metadata. And when you say data node is the actual data. Name node and data node, right? So data node will have your data, where name node will have the metadata, right? Does not contains the data. Okay, now name node, master of the system, maintains and manage the blocks which are presented on your data nodes. Guys, be specific, understand what it is mean. So somebody says including name nodes, secondary nodes, and data nodes. Okay, so please specific. It's saying maintaining and managing blocks which are present on data node. I should be expecting a question, guys. It is more technical like a block. You should understand what is block. You should ask Indra what is block, what we're talking about. All right? Is anybody understand what this mean? This is called master of the system. That's fine. What is the second line? Do you understand? Maintain and manage the blocks which are present on your data nodes. Processes, logs, and structures. Quite bit similar, not exactly the same. Okay, Anubhuti says data is divided into blocks. Okay, good. So I was expecting this question, but you guys have not asked, but that's fine. I'm going to explain you. Now, when I say blocks, blocks is the smallest unit of your data stored in SDFS. Okay, keep this wording, keep this things ready for you. When I say name node, yes, name node maintains the metadata, fine. So when I talk about your block, so it's actually the smallest unit of the data storage in HDFS. Make sense, guys? So anything you store, you want to store in blocks. So please keep remember, do not forget that. This is very important topic, and wherever you say, you will come back to you. So block is the smallest unit of data storage in SDFS. That's the example. That's the definition. Now, when I say storage, you do not store at your master, do you? You don't store, right? So it's saying data nodes, but you wanna maintain them and manage them, right? You want to maintain and manage into a master name node. So it's actually they have a metadata. Am I correct, guys? So we're saying a metadata, right? So you have a metadata. That means you're keeping everything. So you know which block is stored in D1 or D2 or D3. Prasanna, please keep this in mind. You know, this is your answer actually, to be very honest. So your name node, we understand, okay, where you want to store, what you've been stored. All right. Now, what is data node? It's a slave which are deployed on each machine and provide the actual storage, right? Responsible for serving read and write requests for the client. Is it clear, guys? So name node is your metadata, right? And slave is the actual data. That's the place where you read and write your blocks. So blocks are written and by read by data nodes, but they are being managed and maintained by name node. Is that clear, guys? Can you please make it very important? It is really important stuff. Okay, I'll still clear. This is an SDFS, guys. This is into the storage part, not the processing. This is storage. Okay, please be specific. If you miss this, then you'll be in a problem in entire Hadoop. Do not miss it. When you say storage, storage has two parts. One is the name node, one is the data node. Name node is a metadata which holds the and manage the blocks information which is kept in your data node. So this is actual data, this is metadata. Am I clear, guys? Okay. Thank you very much. Good. I'm going to proceed further. Okay, so now let's talk about a name node little bit, more better. So metadata in memory. So let me tell you, name node is actually does not have a physical file where they can keep it. They keep everything in memory. All right. So let me talk about what is the, if you talk about normal metadata and the way they keep it in repository, but here they keep it everything in kind of a memory. So name node will have in memory. The entire metadata is in main memory, right? No demand paging and, file system metadata altogether. You don't go and write everything in file system. You don't write it. Now types of metadata, list of files, list of blocks of each file, list of data node for each block, file attributes, access time, replicate, replication factor, everything is there. Also they got a transaction log. So record file creation and file deletion. If you can see this. So when I say metadata, it keeps track of everything what is happening, right? Keeps track of your blocks, keep tracks of your attributes, when it is accessed, when it is replicated, right? Replication factor would be making a duplicates. So we'll have to talk about it little later on that, right? So name node keep overall file. You can see that keep of overall file directory is structured and placement of data blocks, right? So if you say metadata user info is 132, then P detail is 42. So what is 132 is actually your data nodes. Where all they being having info, right? Where is the detail is 4 and 2. So this is how it's gonna be give you the information. It is very important you guys to understand. Please do not forget. It is I would say a principal part of your Hadoop. If you don't know, then there will be a problem later on. So please be specific. Ask me a question if you have any. Harshit says the FS explain demand of paging. So we don't do paging. See that we're not doing any paging. Paging is a process of using your memory one by one. So Windows use a paging concept. So once the one page is finished, I mean one memory is finished, they actually use a new paging. So there's no demand paging here. Sorry. So that's I said it's been already cleared. No paging system, right? For that you probably have to go and do a little more R&D how Windows works for the paging. So go for memory paging, right, to get more information. Okay, Shabaji, sir, can we explain in P detail one more? Right, just wait, Faji. We'll talk about more in detail here. So just keep this. This is how's the metadata. Keep your question parked for some time. We'll coming back to that. So don't worry, we're coming up because it's the first two classes. I won't think that everything we can answer here. Bhushan saying looks like Ferrari photo is earlier slide demotes name notes to be high configuration. Yes, good. Okay, get to know it looks fine so far. I think we are proceeding. Thank you very much for supporting me because we have to speed up, guys, otherwise we won't be able to make it. So yes, this is a name node and this is the actual. So yeah, yes, it's been given here. The Ferrari is definitely an expectation of everybody, but you drive the local car of your Mumbai and Delhi in India and abroad. Fine. So Abdul is a question. It's if it is memory, why does the path of metadata looks physical location? Well, see, memory gonna be for, so you have to go and talk about where is the master. So there would be master node. So master node would be a physical machine altogether, right? So you will have to have your location. But when you say where you want to keep them, so actually when it comes to the calculation running, it stores into the memory and then it executes. Make sense? Right? So when I say calculation part, when I say running part, it actually stores into the memory. But you have to have a master node there. You have to have a data node there. We'll talk about soon. You'll get to know more. So it says the entire metadata is in memory. So metadata is in memory, right? There would be master node itself. You can't forget them. You have to have a structure there. Okay, so good to know that. Now this is very important, guys. I think this is one of the important factor. I am actually, are we going out of time? Oh, it's already 9 o'clock, guys. So important factor is this, and we have to finish. Is very important. It's one of the important aspects. So guys, how's good to go? Are you guys there for 5-10 minutes more, or you guys okay to bind up, or what exactly? Because this is an important topic and wanted to take off. You guys tell me how you. Okay, a lot of people says okay to continue. Done. So if you can guys okay to 10 minutes. Okay, cool. Thank you very much. Oh, Mohammed says I leave to office, start afresh. Okay, Ankit says start afresh. Okay. Oh, mix. Okay, cool. Tomorrow. Oh my goodness, I got a mix combination now. So let me. Oh, a lot of people has to leave for office as well. Okay, cool. Okay, so Abdul, can you hear me? Can you unmute yourself?
Hey, can you hear me?
Yeah, fine. What do you suggest? I'm in a dilemma. A lot of people say do it because they have to look for a office. There are people saying okay, they need to. There are a few people. I think 5 guys are saying I need to leave for office. What do you suggest? I'm actually confused. If I
It's
continue,
almost
then
half the class. I reckon we probably break here now and
yeah,
continue on tomorrow.
it looks like a lot of people says can we do tomorrow because I think 4-5 guys are there. So we can do it tomorrow. It's a very important topic, right? I don't know because these are basics. If this is clear, entire Hadoop would be clear. If this is not clear, each time there would be a problem. So I think we should continue tomorrow if that looks fine because we have to definitely complete. So how's the speed today, Abdul? How did you like it? So like Abdul, speed was okay or
Yeah, the speed was good. It was main
Yeah.
concepts were quite clearly explained, so that
I
was
am
good.
pretty straightforward apology because I wanted to focus more on the topic. Otherwise, we were not able to make it. Okay, good.
Yeah, no, I found the concepts have been very quite clear, and the last few parts are
Yes,
quite
still.
important. So we would
Yeah.
probably spend more time on
It's
that
gonna
tomorrow.
be repeating all the time. So whatever you talk about master node, name node, this is only you have to look, nothing else. So to be very honest, SDFS processing, SDFS processing. So you'll not go to lose everything. You're gonna be keep coming every time you write. You know that. So it's gonna be light initially. Thank you very much. Okay. So now let's talk about a bit of kind of understanding. Anubhuti, can you hear me?
Yes, Indra, I can hear you.
You ready for the
Yeah.
office? You said, are you ready for office? Or somebody has to go for office?
Uh, no,
You're not for
I'm
office.
at home. I'm on ML, yes.
Okay,
But
no issue.
again, I just want to say that maybe we can cover it tomorrow because it's an important topic
Yeah,
and we will have a question, so it will
definitely.
be broken somewhere.
Yeah, that's right. That's I thought
Yes.
because I'm okay to continue because I'm sitting at home early in the morning in India, but that's fine. But you guys being already. So what do you thought for
Yeah.
today? Did you like this concept? Apology, I have not taken a lot of questions because people asking little deviated and we have to more focus. Otherwise, we won't cover on time.
Uh, no, that's okay. We can ask the questions further as well when the topic has been covered.
Mhm.
And the speed is also okay. The concepts are being cleared, and you are more focused about the concepts. And it's a good class.
Okay, thank you
I've
very
cleared the
much.
concepts.
Yeah, so please give a feedback if you feel excellent, and do let me know if you have any thoughts.
Sure,
Thank you.
sure.
Okay, good. Bhushan, if you can hear me,
Yes, I can.
how are you doing, sir?
I'm doing good. I'm doing good. I liked it. It's going well, and many concepts are getting cleared. It's going good so far.
Okay.
It's good.
So apology if not I've replied a couple of questions of yours or anybody else because we
Oh,
want to
that's
be
fine. That's fine.
more focused.
Yeah, I know.
Okay, good. Thank you very
I
much.
mean, if you think it is fine, we can do that as well. That like you explain us like 15, 20 minutes, and we hold our questions, and then we will ask in one
Correct.
go. If you are okay,
Yeah.
that's
So
a suggestion.
no, that's fine. So what we can do is, if it is relevant with the topic, I always, unmute and get it done. But if it is not, because it's only one or two classes. Hadoop is a bigger class, right? You got a Hadoop is a bigger environment, so it's like questions will be definitely coming in. I love that. I need an interaction because you're guys here to pay your money in time, and I want to get your benefit out of it, right? I don't want you to go by benefit or doubt. I want to go by benefits only. But there would be relevance with the topic. If it is towards topic, it's saving time of everybody because you got 26 people on your batch, by the way, 26 to 30 people. So I cannot take 30 questions at a time, but yes, I'm trying to definitely put some people on interactions. All right.
Yeah.
So please feedback if you feel excellent, and if you want to put some comments there, it would be fine. Thank you very much. Okay. Okay. So we got Guri. Can you hear me?
Yeah, hi.
How are you doing?
I'm good. How are you?
I'm doing well. So probably no questions coming from your side. All well. I have not seen a question.
Yeah, this is my second time. I joined another
Okay.
class.
So you already know
After a
that.
couple
So that's fine. That's
of
fine.
yeah.
So I realize now. So nothing new for you, but you must be revising them. Must be
Yes.
so,
Yeah.
good. So how are you finding this class, Gurin? If things going on or?
Yeah, it's good. I think you should not like. This is just my suggestion. You should not stop for the questions between like one slide, and at the end of the slide, you should answer all the questions. I think that will speed up our
Makes
process.
sense. I take this feedback pretty honestly. This is what I even thought in the morning today. But you know what happens? People are asking, so it looks very uncomfortable because 30 people are there, and if you don't
Yeah.
answer, then it goes for feedback. This guy is not listening to me, which is embarrassing. So I don't
Yeah.
want to get into negative thoughts, but at the same time, we will have to focus. So we have a very short time. 2 hours is nothing. You understand, right? 2 hours
Yeah.
is nothing. So when I normally take a 3 hours class, so when I come in speed is only 1.5 hour. Where after first break you get a good speed, right? So first hour
Yeah.
is always big. No problems. Thank you very much for this feedback. I'm going to keep this up. So I'll go for a slide complete definition and then probably I'll take the question. That make more sense.
Yeah, maybe we can discuss with others the same concept.
Good to know that. Thank you very much. Stay tuned. So you can have just give a feedback if you feel excellent and you have your thoughts there. Thank you.
Yes, thank you.
Okay. Gilfrado, are you there?
Yes, I'm here.
How are you doing?
I just want to know. Good. Yeah, so far so good because I am pretty new about the big data. So, do I have to read the material?
Okay, is that the question only, or you have more?
What's that?
This is the only question you have? You have more?
Yeah, there's a question. I'm saying I should review the material. They recommend the listing tutorials like that.
Okay, well, to answer your question.
Before the class?
Correct. To answer your question, if you read the material, it's fine. If you just go through it, my recording as well as the presentation is enough to explain you the concepts. The rest, what you do is you take a presentation concept, go to the Google, and little bit you can do Googling. Will that be fine? And if you do that before coming to the class, will really help you more better.
Okay.
Yeah. So you go ahead and give your feedback if it is excellent and put your thought if you want, and good to go. All right. Thank you.
Yeah, right. Well, just saying, because I have a previous experience. So I'm just saying, you just have a new term, so I understand. So eventually I get it.
Yeah, no problem. Yeah. Thank you very much for your time.
Thank you.
Okay, so we got Jitesh. Jitesh, are you there? Can you hear me?
Yes, I can hear you.
Okay. So I think one of the suggestions come from Gurinder say that we have one presentation slide complete and then we take in questions. What do you suggest upon?
Right. Yeah, I know I was about to share same input. I think we have too many interruptions.
Yeah, we got 30 people in class.
So,
and the problem is, Jitesh, if you don't answer anybody, people feel bad and they write wrong comments, which is not good for
No, I agree. We should answer, right? Otherwise, we are missing an opportunity to understand the concept. But I think end of the slide is probably a good break or end of each concept.
And then we can, that makes sense. Because see, I am looking for more. Big data is not only technology. Big data is all about a platform to understand. So it's like you have to understand administration and development. You only understand development does not really work, right? You have to understand clusters first, then only go for development.
I agree, and I'm not denying that. I'm not saying that we shouldn't take questions because tomorrow I'll have a lot of questions, so I would expect you to help me and clarify. But maybe you should set the expectation at the beginning of each class, saying that hey, you got to ask questions only at the end of each slide, so we can kind of use that as a refresher as well as opportunity for everyone to ask questions.
Makes sense.
Otherwise, this is sometimes you don't
away.
control that. Yeah. It looks like those. If you are watching like one of the, if you're watching like one of the new movies that they broadcast in, right? You'll have commercials every 5 minutes.
Okay, good. I got to know that what you're talking about. Yeah, it looks very interrupted actually. You don't focus on the concept. Yeah. Okay, good. Exactly. I'll take this positive. I was thinking the same one because I do same thing with the Tableau and other training of mine. So we discuss a concept, then people ask a question, I keep it aside. Once I finish it, I'll go and answer everybody. That makes more sense.
Yeah.
Right?
Yeah, in case if rest of the team doesn't like that approach, you can always adjust.
We'll go back to the same, advertisement in every 5 minutes.
Right.
So how did you feel today, class? Is the concept is clear, Jitesh? That's the importance here.
Yeah, I'm good. Yeah, it's good. Thank you.
So you can go ahead and give your feedback, and if it is excellent, go ahead and excellent, or put your thoughts if it is possible. Right? Thank you very much. So guys, everybody, a request to please feel free, and please give us a feedback. And if it is excellent, put it excellent. And if you feel something else you want to put in, and you want to probably give in different thoughts, please go ahead and give us a thought, and I'll be happy to help you, later on. Okay, so we're good to go. Prasanna, you there?
Yes. Hello.
Yeah, you can hear me?
Yes, Indra.
Okay, so you just keep following what I'm talking about from a cluster, name node, and data node. Hope you're able to getting it now. It's not cleared yet because we just initiated. So we'll get your question
Yeah.
done very soon. The question is automatically answered. So how we happen, how we take the data from different data nodes, and how master data is being taken care. So when we go to the flow, how the program executes, you get your answer. I'm damn sure.
Yeah.
So there would be a flow of programs, how the flow happens, right? So another 2-3 class, you'll be able to make it. So how you finding the class today?
Yeah, it's quite good. I think what's my suggestion is like we are waiting for people to join maybe another 5 minutes, 7 minutes, something like that. If request everyone to be here by exact time so that you can start so that we can gain a 10 minutes more. I think that will be better.
All right, so I think initial 5 minutes which I wait. So yes,
Basically that's a request to all of my friends joining.
yeah, so that's fine. So I'll think 7:02, 7:03. I mean Indian time morning. Another 2-3 minutes we should start getting into. Okay, makes sense. So I would request you to please put on your feedback, Prasanna. What is your thought and how you feel? If it is excellent, put it excellent. If you thought something, you please go ahead and put that. It's always appreciated.
No problem. I'll do that. Yeah.
Yeah, thank you very much. Good. So we are good to go all together. Anybody has any questions, would be happy to help you, and definitely we'll see more how it goes on and how we can use this all together. Ankit, if you can hear me, I am not able to hear you because the mic is muted from your side. Can you hear me, Ankit?
Yeah, hi.
How are you doing?
Yeah, I'm doing pretty good.
Okay, so how you finding the session today?
Yeah, it was good. The concepts were pretty much clear. I also share the similar thoughts as few of the other participants have shared till now. And one thing that I tried yesterday, I tried taking the quiz yesterday, and I realized that probably we have not covered the module.
Yes.
And that was gonna help in all those questions. So I was not able to answer a lot of questions out of
You
that.
have not completed
But then
your
I
first
realized
module. Go ahead.
Exactly. So I realized that part later. But then I think we are going in the correct pace right now.
Okay. Fine. So I think the interruption is there too many, and everybody is requesting. And even I feel there's a lot of questions coming and people asking. I don't regret answering the question at the same time, but I think we should have one, kind of platform where we can have concepts clear first. Let me explain it first, and then probably we can go ahead and take questions. What do you suggest, Ankit?
Yeah, I think that will be the better approach.
Yeah,
I mean, we can have a point of time during the session where we can take questions from everybody rather than having frequent interruptions.
Yeah, so we'll say one slide, one concept is finished. For example, we're going to go for this concepts of, how do we have a file blocks and how we do that, how do we calculate and all, and then they can start asking me question. That will be more helpful.
Yeah.
Right?
Yeah.
So that's good, and thank you very much for today's session, and appreciated the way you guys have taken up, and I think it's a lot of interaction happen, and interruption with interaction, I think it's being a little more. We have to just coordinate and control. Rest things looking fine to you, right? So concepts are clear.
Yeah.
Okay, good. So I would request you to give your feedback. If it is excellent, put it excellent. If you have any thought, please go ahead and do that. Right?
Yeah, sure.
Right. So guys, that's all for today, and I think we are good to go from the understanding point of view. I'm not sure. Is Vijay? Can you hear me? Is your mic is able to? Can you able to talk to me? Are you able to hear me, or how's that? Okay. So still there would be some issue, Mike. No issue, Vijay. That's fine. Yes, interaction is between sometime. So what do you think? Yes, first 5 minutes will be Q&A and 10 minutes. Okay, that's fine. So yes, we'll have to manage the interaction, and we'll have to definitely take this forward to the concepts first, and then we have a question answer later on. Good to know that, and thank you very much for pleasant date of mine, and you guys have been an excellent candidates where I've been loving to talk to you guys and get to more. So there are a lot of teaching coming ahead, guys. Just keep cool and calm, and keep your question ready. If it is relevant, fine. If you park it, don't get minded at all. This is a professional course. We're not here to criticize anybody here, and there's nothing personal. You will just keep it a park. That means you're parking for some time, and then I'll come back to you on the questions. If I don't recall, please recall me, Satyendra. There's a question which is being still lying. That's fine. So have a good night, everybody, and have a good day here, hoping in India abroad, depending on the time frames. And don't drink drive. Take a good time with you and family, and also for Hadoop. Take care, guys. See you soon tomorrow. Bye bye.